Hello, I'm Isaac, and I'm going to be going over the classification neural network project I designed for SENG 475. The neural network I designed is known as a feed-forward neural network or multi-layer perceptron. It uses multiple layers of nodes to approximate classification functions. Each node performs a weighted sum of its inputs that is then fed into a nonlinear function. This is used to introduce nonlinearities into the model that would otherwise not be present with just weighted sums. Backpropagation is used to calculate the error of the network and update the network parameters accordingly. For more advanced problems, alternative architectures are used, such as convolutional neural networks or recurrent neural networks. The project is composed of two main programs, train network and test network. Here you can see the command line arguments of train network. Notably, training data can be either read from a file or read from standard input, and the trained network can be either output to a file or output to standard output. Test network has fewer command line options. However, it can also input test data and train network data from either a file or from standard input, and test results are either written to a file or to standard output. This command uses the MNIST handwritten digits dataset to train a neural network. When the output network is written to a file, as it is here, the train network command will output the latest value of the cost function to standard output. This is useful for visualizing the convergence of the neural network. This command is similar, however I specified the -I, indicating a pre-trained network should be used. You can see that training picks off where the previous training command left off. Here, the MNIST dataset is piped into test network. When a labeled dataset is used in test network, it generates a confusion matrix, the format of which is further described in the README. However, you can see here that 8 is misclassified as 0 6 times, and it is correctly classified 918 times. The model has an overall accuracy of 95.44%. In this command, I use awk to strip the last column of the MNIST test dataset, the labels. When train network is fed data that doesn't have labels, it outputs the raw predictions and the corresponding confidence. Here you can see that not only test data can be piped into test network, but also network data. Train network here is being trained on a binary OR classification. The trained network is then being piped into test network, which is then generating the proper confusion matrix. This command is stripping the labels off of the binary OR test data, which allows test network to output the raw predictions. You can see the input to the network, the prediction, and the confidence. Last, I will demonstrate an image being piped directly into test network. This uses a Python script I made that converts the image into a CSV format that test network expects. You can see here that the classification is 5 correctly, but with a low confidence of 18%. If we try again with a 6, you can see that the prediction is a 6 with a higher confidence. 7s usually get good confidence ratings. So it correctly predicted it was a 7 with a very high confidence rating.